Hi everyone. This chapter is going to be about proving triangles congruent, okay, and what information we can get based off of that because they're congruent. So today's lesson is going to be two parts. One, just what does it mean to be a congruent figure? And two, what are the different ways, well, at least some of them, that we can prove triangles congruent? So first and foremost, what are congruent figures? So basically, a congruent figure is one that has just been rotated, it's been turned, or it's been flipped, it's the reflection. Translation means it moves, like it slides. So these three things, rotation, reflection, and translation, it's still the same shape, it's still the same figure, it just moved. Okay, so we're gonna be working with both of those. So like, what does this mean, the reflection? Okay. So congruent angles are just basically angles that have the same measure. And then same thing with congruent segments. They are just segments that have the same measure. Okay. So if we look at the example below, we're going to list some congruent angles and congruent sides. So remember that these tally marks represent which one it's congruent to. So there's one tally mark here, one tally mark. So those two are congruent. Two here, those two are congruent. Okay, and you need to make sure that you follow order. So what I mean by that is, let's say I am talking about the congruent sides right now, and I say A is congruent, or AB is congruent to DE. Notice I went 3 to 1, 3 to 1 for the arcs. Okay, I can't say AB is congruent to ED. That doesn't follow the same order. And if we go over here, okay, follow the same order, AB, DE. So you can actually look at a figure, or you can look at what's known, this is known as the congruent statement. And from the congruent statement, you can also see where the order matters. So let's say I want to do two arcs. So B to C, green to red, so I have to go green to red here. So BC is congruent to EF. Okay. And then finally, CA is congruent to FD. Now, I can always flip these in the sense that I can write this as AC is congruent to DF. That's the same thing. I just can't switch the order. So if I go from C to A, then I have to go F to D. If I go A to C, I have to go D to F. Okay, so order matters when you are writing congruency. And then the angles are pretty straightforward, right? So angle A is congruent to angle D. Notice 3 arcs, same place in the congruent statement, blue and blue. Angle B is congruent to angle E, and angle C is congruent to angle F. Again, C, F follows the same order. So C is not going to be congruent to D if you set up your problem correctly. Okay, so keep in mind when naming polygons that you follow order and you do not jump across the polygon. So what I mean by that is we don't go, okay, so like B to C is congruent to E to D. I jumped across the polygon. Okay, let's go ahead and look at practice example number 2. And, you know, when things aren't marked on the diagram, sometimes, you know, people think they can't do the problem, but you can because there's a congruent statement here. So I look for the same place that it's listed in both. So if I want angle A, then I want angle R. It's in the same location. Okay. If I want angle C, I go to the third location then, and that's going to be angle T. Then we have angle U, so that's going to be angle D. Okay, now the segments, we have to follow order. So A to B, R to S. U to R, so I'm going to go D to A. And then S to T, B to C. So I'm hoping that you are recognizing that there's order along the congruent statement. Okay. All right, let's move on to the next example. And we can do algebraic problems here because remember, if a polygon is congruent, then that means that all the angles are congruent to the corresponding polygon, and all the segments are congruent to the corresponding polygon. So what I mean by that is this says right here that these two triangles are congruent. So that means that FG is congruent to JK, and GH is congruent to KL, and so forth. So if I'm looking at this example, I see FG, that's going to pair up with JK, and since those are congruent, I can set them equal to each other. So 12 equals 3y minus 15. So y equals 9. Okay. Which then, my value of KL would also equal 9 since it's just represented by y. Okay. And then I have angle K. Angle K is going to be in the middle here, so I need to match it in this triangle, so that's going to be angle G. What do you know? I have information there about that angle. So I get 4x equal 128, so x equals 32. Okay. So the biggest thing to know here is just that when polygons are congruent, then all the corresponding angles and sides are also congruent. Okay. All right. Let's go ahead and go on to the next stage. Okay. And let's review the reflexive property. So remember that the reflexive property is a segment or angle is congruent to itself. And you're going to be using the reflexive property quite a bit. So if we look at this first triangle, we have FH is congruent to FH. Why did we say that? Because each one of these individual smaller triangles shared FH together, meaning they shared the same side. Okay, in the next example, sometimes it's kind of hard to see these triangles when they are kind of built on top of each other. So one thing that we can do is separate them. So we have P, Q, R, and then we have Q, T, S. So we can see by looking at our triangles that they share a common angle. Now you have to be careful to not just write, say, angle Q is congruent to angle Q, since it's shared by multiple vertices. So we're going to say angle PQR is congruent to angle SQT. So it's the same angle, okay? It's represented by the same vertex, so you could use the reflexive property here. All right. Practice example 3. Is we're just going to try to prove this triangle congruent. So right now, the only way you guys have to prove figures congruent is if you know that all parts are congruent. So all the angles of corresponding figures are congruent, and all the segments of corresponding figures are congruent. So let's see if we can figure that out. So example A is congruent to E. If you look at the diagram, it's already marked for you. So this is just congruent angles. Okay. Then angle ACB and angle ECD, they are created by intersecting lines. So those are going to be vertical angles. And what do we know about vertical angles? They're congruent. Okay. Angle B is congruent to angle D. So once again, that's just congruent angles. And then it says AB is congruent to ED. It's already marked on the diagram for us, so this is just congruent segments. Okay. And then this one right here says AC is congruent to EC. And if you go back to the given, it says C is the midpoint of E. Therefore, this is the definition of a midpoint. That's the reason why those two are congruent. Okay. And then the same thing here, it says C is the midpoint of BD. That's why BC is congruent to DC. And we have, again, the definition of the midpoint. So we know that these two are congruent, and we know that these two are congruent. And notice in the congruency statement that it followed order. So I went B to C, D to C. 1 arc, 3 arcs. 1 arc, 3 arcs. Okay. Now notice I have all 3 triangles congruent, all 3 angles congruent, and all 3 segments are congruent for corresponding sides. So we can conclude that triangle ABC, again, notice the order, 2, 1, 3, is congruent to 2, 1, 3, EDC. And this is just the definition of congruent figures. Okay. All right, moving right along, we have the triangle angle sum theorem. So hopefully we know this one from previous math classes, but all angles in a triangle, which there's only 3 of them by the way, always add up to 180 degrees. So if we have triangle KYZ is congruent to triangle PQR, which means that all corresponding sides and angles are congruent, can we find out the measure of Q? Well, measure of X is 70 degrees. Measure of R is 75 degrees. Find the measure of Q. Well, let's go to our congruency statement, and X is in the same location as P. So P is 70 degrees. Well, now do I have 2 angles to find the third angle? I do. 180 minus 70 minus 75 gives me 35 degrees. So angle Q is 35 degrees. Not that you needed to do this, but you also could have said, okay, R is in the same spot as Z, so that's 75 degrees as well. Okay, let's move on to the next page of. Sorry, ahead of time, I know this lesson's a little bit long, but we needed to kind of cover 2 topics in one. So tomorrow, your video, or I should say the next video, is going to be about proving triangles congruent and actually writing proofs. So you're not writing any proofs today, but in order to do that, we need to figure out the ways to say that triangles are congruent without having to prove all sides and all angles are congruent, because that's a lot of work. So before we do that, we need to understand what an included angle is. So an included angle basically means it's an angle formed by 2 adjacent sides. So if I'm looking at side AB and CB, the included angle would be B. Okay, so it's in between the 2 sides of the angle that was formed. If I was looking at BA and AC, then the included angle now is A. So the included angle could change depending on which sides you're working with. So notice that it's in the middle. And then finally, if I was working with AC and BC, then hopefully we see the included angle then would be C. Now, the included side is the side in between two angles. So if I was working with angle A and angle B, then the side between them would be AB. Okay. Notice basically it just is the side made up with the two angles that you're working with. Okay. And then if I have A and C, the included side would be AC or CA, same thing. And then if I have B and C, the included side would be BC. So notice it's just made up of the angles that you're working with. Okay, the first postulate that you're going to learn, and you're going to learn 5 eventually today, we're just going to learn 4. The first postulate is side, 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 and we abbreviate this as S, 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 S. And we like this one because all you need to recognize, you don't have to worry about included angles or side, you just need to know that 3 sides are congruent. If 3 sides are congruent, then it follows that the rest of the triangle will also be congruent. Okay? So 3, 1, 2, 3, 1, 2, 2, 1, 2, 3. So we would say that triangle ABC is congruent to triangle XYZ by SSS. So 3 sides congruent, corresponding sides are congruent, okay? Then therefore the triangles are congruent. Again, these are, if you want to kind of think of it as shortcut ways so that you don't have to prove that all corresponding parts are congruent. Now, if we're looking at the example listed below, right now it only has 2 sides marked congruent for us. However, we have properties that allow us to prove a 3rd side congruent. That is, in this case, that BC is congruent to BC by the reflexive property. So let's go ahead and mark that then. Now I have 3 congruent sides, and I can say that triangle ABC is congruent to triangle DBC by SSS. Okay. All right, let's go to the next page. The next one we're going to work with is side, angle, side. So if you look at side, angle, side, notice where the angle is. It's in the middle. So when we're working with SAS, that means we want the included angle to be between the 2 sides. Okay, so what that would look like when you proved it is that you have 2 sides congruent and then the angle in between the 2. So in this case, B is congruent to Y. So we would say that triangle ABC is congruent to triangle XYZ by SAS. Okay, you could not put the angle over here because it's would not be included between the 2 sides. So sometimes it helps to actually highlight the 2 sides so that you can see where the angle needs to be. Okay. All right, so in this example it says show why XYZ is congruent to WZV. And since it's by SAS, we know that we want the angle in the middle. Well, again, this angle is made up of intersecting lines. Intersecting lines, we have vertical angles. So angle XZY is congruent to VZW. And the reason being is because vertical angles are congruent. Okay. Again, order matters when you're working with congruency. So I want XZY. So I started with the 1 mark side, so I had to start with the 1 mark side over here, ZVW. Order matters. Okay. All right. So far we have SSS and we have SAS. The next one we're going to do is known as angle, side angle. ASA. Again, note that the side's in the middle. So we want the included side. So let's say we're saying A is congruent to X, B is congruent to Y. Which segment would we also need to be proved congruent? The one in the middle, between the two angles, angle, side, angle. So we would say that triangle ABC is congruent to triangle XYZ by ASA. A stands for angle, S stands for side. So I have two angles congruent, and then the side is in the middle. And let's go ahead and mark my side congruent so we see that. Okay, and then the last one we have is angle, angle, side. So AAS, or it can be SAA. Okay, now with angle, angle, side, notice that the side is not in between the two A's. So we want a non-included side this time. So if I said angle A is congruent to angle X and B is congruent to Y, I need either AC is congruent to XZ or I need BC is congruent to YZ. Okay, the one I don't want to work with is this because that one is included. It's in between the two angles. So we'll just mark this one. So we can say triangle ABC is congruent to triangle XYZ by AAS. Okay, so the four ways that we have to prove triangles congruent is SSS, SAS, ASA, and AAS. There's two that sometimes people like to use, but we cannot use them. So the first one is SSA. We do not spell any bad words in math backwards, so no bad words in math. And then another one that sometimes people like to use, but we can't use is angle, angle, angle. And in math class, we have no car trouble. Okay, so no bad words and no car trouble in math class. Okay, last page. We're getting there. So what we're going to do is we're just going to match the postulate, the congruence postulate, with the diagram. So the one I always like to do first is SSS because that's just proving three sides congruent. So if we look at all these diagrams, okay, if we look at E, we have two sides congruent, but then they share a common side, so that means a third side will be congruent. So E would be congruent by SSS. Okay, all right, let's look for side, angle, side. So we need two sides congruent. Looks like C is the only one that's going to allow us to do that. And then make sure that the angle is in the middle between the two sides, which it is. Okay. Now, angle, side, angle, and angle, angle, side are the two sometimes that we get mixed up. Notice that the side has to be in the middle for ASA. Okay, so if we look at B, we can conclude that, if we look at A, we can conclude that these are also congruent by vertical angles. Is that side that's congruent between the two angles? Hopefully you would say no. The included side would be here. So then let's look at B. This is congruent to itself by the reflexive property. Angle, side, angle. So this is B and this is A. Okay. The last thing we're going to do is you're going to be given figures and you have to decide by SSS what would you need. So by SSS, we need three corresponding sides congruent. I have one right here. I have two. I need the third. So we would need that AB is congruent to DE. Okay. Then if I wanted side, angle, side, I need the angle in between the two sides. So these are my two sides that are congruent. So the angle that's in between is C and F. So angle C is congruent to angle F. Okay. All right, let's take a look at the next example. So we want side, angle, side, and then SAS. So let's start with side, angle, side. So we know that this is congruent to itself. I have that these angles are congruent. So if I want side, angle, side, I need the side that includes the angle. So these two sides. So RE is congruent to CT. Remember that ordered matters. And then if I want angle side angle, okay, I have the angle that's in red. I have the side that's in red also. And then I need the other angle making that side included because S is in the middle. So that would be this angle. So we would say angle RTE needs to be congruent to CTE, because then it allows the side to be in the middle of the two angles. Okay, let's do one more example. Let's go down to this one, because this, like I said, this is the one sometimes that we forget which one's included and which one's not included. So angle side angle, that means the side needs to be in the middle. So I have angle here and angle here. This is my side. I need the side to be in the middle, so I need H is congruent to K. Okay, and then the last one is by angle, angle, side. So I don't want the angle, or excuse me, the side in the middle. So then I can't use H and K, right? Because that would make the side in the middle. So then I have to use M and J. Okay, so on tonight's homework, you're going to be working with congruent figures, and then there's going to be a bunch of examples where you just have to say the way it's congruent. Is it by SSS, SAS, AAS, or ASA? Again, as always, thanks so much for watching. Appreciate it. And remember, no bad words in math and no car trouble.